This simulation shows a bunch of different relationships for a parallel plate capacitor. So up here it shows the capacitance in picofarads, the top plate charge in picocoulombs, and the stored energy in picojoules. Over here is the power source, which is just a battery, and you can change the voltage that comes from the battery with this switch. Then there's a wire that connects the battery to the capacitor, and up here there's a switch that we can move to disconnect the capacitor from the battery. This arrow changes the distance between the plates, and this arrow changes the area of the plates. There's also a voltmeter over here, and it will show us the voltage or the potential difference between the two plates. The first thing this simulation shows is that the capacitance is dependent on the geometry of the capacitor. It is directly proportional to the plate area, so if we increase plate area, capacitance also increases. And it's inversely proportional to the distance between the plates, so if we increase the distance, capacitance decreases. It also shows that plate charge and stored energy are both directly proportional to the voltage, so when we increase voltage, so does the plate charge and stored energy. And they're also directly proportional to the capacitance. So if we increase capacitance, plate charge and stored energy also increase. It also shows that when you disconnect your capacitor from the power source, there's now energy stored on the capacitor. And when we change the capacitance, we'll notice that the stored energy changes and the voltage changes, but the plate charge does not, and that's because the amount of charge that's on the plate is what it collected from the battery, and now that it's not connected, the charge has nowhere to go, so all that charge is just going to stay stored on that plate. We also know that voltage of a capacitor equals the electric field times the distance between the plates. So now if we do everything to maximize all of the things and we disconnect from our power source, we know that when we increase the distance between the plates, that's going to increase our voltage and our stored energy. And also, electric fields are stronger when electric field lines are closer together. So that means if we decrease the plate area, that's also going to increase our voltage and our stored energy. So the point that I'm trying to make is if we want to have an infinite amount of stored energy, all we have to do is find a shrink ray and shrink these plates down to infinitely small.